This is SpaceTime, Series 28, Episode 85, for broadcast on the 16th of July 2025. Coming up on SpaceTime, unlocking the secrets of the Moon's mysterious far side, discovery of the Sun's Helicity barrier, shedding new light on the solar wind, and the European Space Agency move another step forward in developing their next generation of orbital launch vehicles. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists have discovered extended volcanism spewing across the ancient lunar far side South Pole region for at least 1.4 billion years. The findings, reported in the journal Nature, identified two very distinct volcanic phases on the lunar far side, reaching their peaks at 4.2 and 2.8 billion years ago. The Moon's near and far sides exhibit striking asymmetry, from topography and crustal thicknesses through to volcanic activity. Yet the origins of these differences have long puzzled scientists. China's Chang 6 mission, which launched back in May 2024, challenged this enigma by returning 1,935.3 grams of material from the lunar far side's South Pole Aitken Basin. The South Pole Aitken Basin is the Moon's largest, deepest and oldest known impact structure, measuring some 2,500 kilometres in diameter. The samples returned by Chang 6 arrived back on Earth in June 2024. Previous studies had already indicated that the Aitken Basin was formed by a colossal impact some 4.25 billion years ago, and that would have released energy greater than 1 trillion atomic bombs. But the effects of this massive impact on lunar geology and thermal evolution was one of planetary science's greatest unsolved mysteries, until recently. The new analysis of the samples shows volcanism erupting across the basin in two distinct volcanic phases, at 4.2 and at 2.8 billion years ago. And that suggests that volcanic activity must have persisted for at least 1.4 billion years, which is far longer than previously thought. And the new findings don't end there. Measurements of paleomagnetic intensity in basalt clasts revealed a rebound in the Moon's magnetic field roughly 2.8 billion years ago. And that suggests that the lunar dynamo, which generates the Moon's magnetic fields, fluctuated episodically rather than fading steadily away. The studies have also shown that the lunar far side mantle has significantly lower water content than the near side mantle, and that indicates that volatile elements are unevenly distributed within the lunar interior, adding yet another aspect to the Moon's asymmetry. Finally, a geochemical analysis of lunar basalts indicated an ultra-depleted mantle source, likely resulting from either a primordial depleted mantle or massive melt extraction triggered by large impacts. These findings from Beijing's Chang 6 mission are fascinating, and they highlight the role that major impacts have played in shaping the Moon's deep interior. This is SpaceTime. Still to come, discovery of the Sun's Helicity barrier shedding new light on the solar wind, and Europe moves another step forward in choosing its next generation of orbital launch vehicles. All that and more still to come on SpaceTime. A new study has confirmed the existence of a region of the Sun which astronomers are calling the Helicity barrier. The findings, reported in the journal Physical Review, helps explain how plasma streaming out of the Sun is heated and accelerated in the outer solar atmosphere known as the corona. Alright, let's go back to first principles here. The Sun's core is a temperature of about 15 million degrees Celsius. By the time photons created in the core reach the Sun's visible surface, the photosphere, temperatures have dropped to around 6,000 degrees. But interestingly, further out in the Sun's corona, temperatures increase again to over 1 million degrees. Now that's a feat which seems to defy the laws of physics, which suggests that things should be getting cooler the further away they are from a heat source. So that means something out there must be causing things to heat up again. It's a paradox we've often talked about on this program, and it's one which has been puzzling scientists for decades. Furthermore, the constant outflow of plasma and magnetic field from the Sun, which is known as the solar wind, is accelerated to supersonic speeds in this same region. Now, something called turbulent dissipation, the process by which mechanical energy is converted into heat, is believed to play a crucial role in both these phenomena. However, in the near-Sun environment, where plasma is largely collisionless, the exact mechanisms of this dissipation remain elusive. Now, new observations gathered by NASA's Parker Solar Probe during its ultra-close encounters with the Sun have allowed scientists to directly explore this extreme environment for the first time, in the process providing crucial data which is helping to unravel some of these mysteries. Now, during its latest flybys, Parker swooped down to within 6.2 million kilometres of the Sun's surface, and that's closer than any other spacecraft ever. Its record-setting close encounters have also seen the spacecraft reach speeds of over 687,000 kilometres per hour. That's faster than any other vehicle ever, all while enduring scorching temperatures of more than 930 degrees Celsius. And this spectacular endeavour has allowed scientists to gather enough evidence to suggest that a long-hypothesised Helicity barrier really does exist, and it's actively altering the nature of turbulent dissipation. This previously theorised effect creates a barrier to the turbulent cascade of energy at small scales, fundamentally changing how fluctuations dissipate and thus how plasma is heated. The study's lead author, Jack McIntyre from Queen Mary University, says the results confirm the presence of the Helicity barrier, and they allow scientists to account for properties in the solar wind that were previously unexplained. These include the discovery of protons, which are typically hotter than electrons in this region. And the authors also identified the specific conditions under which this barrier occurs. They found that the Helicity barrier becomes fully developed when the magnetic field strength becomes large compared to the pressure in the plasma, and becomes increasingly prominent when the imbalance between the oppositely propagating plasma waves that make up the turbulence is greater. And critically, these conditions are frequently met in the solar wind close to the Sun, and that's exactly where Parker Solar Probe's been exploring. That means the effect should be fairly widespread. And that answers some long-standing questions about coronal heating and solar wind acceleration, such as the temperature signatures seen in the solar atmosphere and the variability of different solar wind streams. This allows scientists to better understand the fundamental physics of turbulent dissipation, the connection between small-scale physics and the global properties of the heliosphere, and it will allow scientists to make better predictions about space weather events, which can affect life here on Earth. This is SpaceTime. Still to come, the European Space Agency narrows down its list of potential candidates for its future orbital launch vehicle requirements. Later in the science report, researchers discover how to use lightning to produce ammonia gas out of thin air. All that and more still to come on SpaceTime. The European Space Agency has narrowed down to 5 its list of potential candidates for future launch vehicle service providers. The 5 were pre-selected to move forward following the completion of the first stage of the ESA invitation to tender for the European Launcher Challenge. The successful companies include ESA Aerospace, Maya Space, Orbital Express Launch, Payload Aerospace, and Rocket Factory Augsburg. The European Launcher Challenge is part of ESA's plan for future European space transportation services, with the aim of promoting a greater choice of European launch services and, as a result, increased competition. It's similar to what NASA's been doing in the United States, using different commercial launch service providers like SpaceX, the United Launch Alliance, Blue Origin, Northrop Grumman, Sierra Space, and Rocket Lab. The European Launcher Challenge selection process is a 2-stage competitive tender. Successful companies will need to be able to prove that they can provide launch services between 2026 and 2030, and also demonstrate an ability to further upgrade their launch vehicles to achieve high capacities. ESA will provide each of the 5 selected companies with up to €169 million in seed funding in order to further develop their launch systems. ESA's Director General Josef Aschenbacher and the Director of Space Transportation Tolka Nielsen told a packed media conference after the announcement that the agency will now consolidate the proposals for its ministerial level meeting, which is slated for November.
The ITT, as I mentioned, will go out next week. Then, of course, after that, the companies will respond. But we plan to have an evaluation this year of identifying who are within the frame of the ELC, the ones selected. And then, of course, this will be brought towards the ministerial for funding. But I'd like Tony to provide a few more details.
I'll just add that to ask the precise question, when will the contracts be placed? And that will only be after the ministerial, when we have the subscriptions according to a fair contribution scheme. So we have no geographical return constraints on this undertaking.
This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study warns that extended drought and warm weather is changing South Australia's marine ecosystem. A significant flood in the Murray-Darling Basin in 2022 and 23 gave Flinders University researchers a rare opportunity to analyse conditions that damaged biodiversity and water quality for both marine species as well as local ecosystems. Their findings, reported in the journal Remote Sensing, also showed that periodic flooding of the Murray River provided a major risk. Scientists have developed a way to use lightning to produce ammonia gas out of thin air. A report in the journal Angewandte Chemie International claims this new, more efficient method brings researchers closer to the sustainable production of ammonia and also transition to a hydrogen-based economy. Ammonia is one of the world's most important chemicals, and it's the main ingredient of fertilizers, which account for almost half of all global food production. Well, it turns out that people feel more comforted by AI-generated words of emotional support if they believe that these words are actually coming from a human rather than a program. The findings, reported in the journal Nature, followed a study designed to explore the limits of AI chatbots as a source of emotional support. Scientists from Israel and the United States conducted a series of experiments in which more than 6,000 people were either told they were interacting with an AI chatbot or with a human, but they were all given AI-generated responses either way. The researchers found that responses which participants thought were human elicited more positive feelings, and participants rated these as being more empathetic. Samsung have finally released their new super slim Fold and Flip Z7s in the glittering New York ceremony in Brooklyn, just across the East River from Manhattan. But while these phones are true technological marvels, it turns out they're not cheap. With the details, we're joined by technology editor Alex Zaharov-Reutt from techadvice.life.
Well, this was the annual Galaxy Unpacked event. They actually have more than one because they have the regular bar phones and then they have the folding phones often 6 months later, or usually. And this time we have the Galaxy Z, or Z as we would call it, Fold 7, the Z Flip 7, the Flip 7 FE, which is the fan edition, a cheaper version of the phone that turns into the smaller pocketable phone, and also their new Watch 8 and Watch 8 Classic devices, which is their answer to Apple Watch, Pixel Watch, and all the other smartwatches out there. Now, Samsung has spared no expense in making these the most spectacular devices that they have. The Fold 7 is the hero. It's got the latest Snapdragon 8 Elite for Galaxy chip, so that's a better chip than the regular Snapdragon 8 Elite used in competing phones. It's got a 6.5-inch screen on the outside, so it feels like a normal phone with a large screen. It's the correct width when you're holding it closed. But when it's open, it's this gorgeous 8-inch display. The thing is a square, so it's not even a rectangle. So it's like the sleekest little book you ever saw. And it's 4.2 millimeters thin when it's open. And when it's closed, it's 8.9 millimeters. So I held that next to my iPhone 16 Pro Max, and it feels like it's exactly the same width. But of course, you can open it up. Now, even though they have made the phone a lot slimmer than the previous iteration, the battery life is the same. In fact, there's 1 hour extra video playback, but it's the same capacity, 4,400 milliamp hours. And so they did alchemy to do that. They had to make everything slimmer and smaller inside. They had to shrink the coatings on the screens, but they still have Corning Gorilla Glass that's the latest and greatest. And one thing they had to take away, though, was the digitizer. So this large tablet phone is the first one that isn't compatible with the S Pen. We also have prices now in Australia. It starts at $2,899 for the 256 gig model with 8 gigabytes of RAM. And then we have the 512 gigabyte model. Now this is for $3,099, also with 12 gig of RAM. And the 1 terabyte model comes with 16 gig of RAM, and that's $3,549. So, I mean, that's a big jump over what used to be the most expensive phone, the Samsung Galaxy S25 Ultra or the iPhone, Pro Max range. But I'm holding this phone in my hands right now. I mean, it is a stunning, stunning phone. And it really, if this is what the Galaxy Z Fold was like originally, it would have just blown people away. It has taken 7 generations to get to this point, but it is quite stunning. And they'll be available in Australia in early August. Of course, there are a whole range of pre-order offers. We do have the Flip 7, the one that is a phone that folds in half. That's also thinner. The front screen is now 4.1 inches. It goes all the way to the edges. You do have cutouts, obviously, for the cameras. And inside, it's a 6.9-inch screen. So this is also a beautiful phone that has plenty of space. The Flip 7 Fan Edition, the FE, that's $14.99 as opposed to $17.99 for the actual Flip 7 itself. That one's based on the Flip 6, the one from last year. So it's got the same outer screen. It's basically the same phone as last year, but with the upgraded processor and the new One UI 8 and Android 16. So that's the quickest that Samsung has ever launched a new operating system. And there are various multitasking capabilities that are designed for foldables, which they've designed in conjunction with Google. And also Gemini is all the way through this device. I mean, they're calling it a multimodal device. Not only is it able to help you with all of the things in your digital world, but the camera can see and help you with anything in your physical world. Are you unsure about what outfit you want to wear for going on a hike? You can show it the various clothes you have and it can give you advice. Do you need help fixing a broken motor or pump or something else? I mean, you can show it anything. There was video of a young skateboarder and one of the colleagues was asking the phone about what's the good sort of skateboarding tricks to do in the area that they were on. And the phone, Gemini, was giving really useful advice. So it's quite amazing how far...
Can't you do an ollie, let's be honest?
Well, the phone itself can't, but if you're holding it, you can do an ollie, and just make sure you buy a case for it so it doesn't go flying out of your hands. But look, they've done an incredible job. Their AI is very advanced. It actually shows how far behind Apple is at the moment, despite the fact they talked up AI to some degree at their Worldwide Developer Conference. And of course, there's the talk that Apple's going to be buying Perplexity, which is one of the big AI companies out there, currently valued at about $14 billion US. The talk is they're going to buy it for $30 billion. And if they do that, and it works beautifully in conjunction with AIs from Gemini and OpenAI and others, that'll sort of put Apple back in the game. But at the moment, the new watches are fantastic as well. I mean, we haven't got time to go into them all, but the number one ecosystem around the world is Samsung. I mean, Apple's up there too, but Apple just makes smartphones, smartwatches, tablets, computers, laptops, professional machines. Samsung makes all of that too, but they also make everything for the connected home, your robotic vacuum, your giant fridge with, a giant huge tablet on steroids.
Everything for AI to keep an eye on you no matter where you are and what you're doing.
Well, that's true. But Samsung also made a very strong, they started off by talking about how secure their platform was. I mean, you can actually run a lot of these AI things on the device by itself. I mean, they do say in the settings, look, if you want the most advanced AI, yes, you'll have to go to the cloud. But just like Apple made promises about how the information going to the cloud is safe and secure, Samsung's made the same promises too. And obviously we're yet to see how they're lived up to. But companies know that consumers are fickle and that privacy is becoming more of an issue. The more that companies try and pry into our private lives, the more people really want, once they know, they want privacy. I saw a graphic on X today about how when you pay for something through Google Pay on your Android smartphone, Google knows what you're buying, where and when, and they're keeping records of it all. With Apple Pay, according to this infographic that I saw, Apple has set it up so it does not know. It doesn't know what it is you purchased or where you purchased it from. I mean, obviously the transaction has to go through, but it's effectively been anonymized, whereas Google is capturing all that information like the credit card companies were and probably still are to this day. So there's definitely differences of the way companies are working and treating our data. But certainly when it comes to Android smartphones, the market leader is unquestionably Samsung. I mean, Google comes up as a very close second, and then you have all the other players who are trying to give you extra features, but for mid-range money, as opposed to the higher prices that Samsung can command by being the market leader.
That's Alex Zaharov-Reutt from TechAdvice.life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. Or by becoming a SpaceTime patron, which gives you access to triple episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.